Good morning.
Good morning.
Right, I trust you're all doing very well. Thank you so much for the opportunity. I would want to thank the leadership of the Computer Science Society for inviting me to give a small talk on blockchain and the Web 3.0. I also realize there are other great speakers on the bill. The proud sponsors for this program, I think, is Hive, right? Am I mentioning that correct? Okay, good. Thank you for supporting the students. It's great to have the industry here and how we mix up to see if we can make a very smooth bridge between academia and the industry. So you're welcome to stay, and have wonderful interaction with our students. Okay, so I acknowledge your presence, also the big man who just spoke before me. Yeah, it's been a while. Yeah, I know this man. Yeah, okay, so I would continue to share with you a couple of things that I know about blockchain, and even if you like Web 3.0 and something. I think that most of you read a lot, so you know some of the things I will be saying, most of you would know about them already. So I wouldn't really speak for long. I will be touching on a few things and then see how our expert technicians can throw up pictures on the board for you to see. How the internet actually came about. So as the word goes, internetworks. Okay, so we are trying to see how a couple of internal networks in several organizations can be linked up together just for us to be able to share information across. Okay, so the bedrock of all our agitations and what we are moving on to do in the digital space has been on information. How can we share information easily? Okay, so that has always been the question. How can we share information easily? If we are all working on a project, how do we ensure that we can share information or communicate seamlessly? And like the gentleman was talking about at ARPANET, it was actually born out of research. The internet was born out of research. A group of researchers were looking at how they can, again, effectively exchange information or do their daily communications. And then the idea came up that, well, we could link up networks, you know, and then and see how this works. And actually it worked. Actually it started within the research organization. They were able to practicalize that, and then now they made it public. Guess where it came from? The USA. Okay, right, so what about the World Wide Web? So the World Wide Web also came from research. Okay, so that points you to how significant research is. Now, this time from Europe. Okay, so there is an organization called CERN, C-E-R-N. I don't know if you guys have heard of that. Okay, now there was a gentleman at CERN, he's called Sir Tim Berners-Lee. Sir Tim Berners-Lee. You can throw his picture, I think he's even still alive, I think. So in the 1980s, this guy was a computer scientist like you are. Okay, so this guy at CERN, which is the European Organization for Nuclear Research, he was contemplating in this research group, how can we efficiently share documents across and files across? Are you guys with me? Okay, so and information across. So that was his thinking, right? So today maybe you are a student here, you are thinking about a problem. How can this be done? How can that be done? Right, so if you think through it very well, you research on it very well, one day you'll be coming up with a breakthrough technology like Sir Berners-Lee, who eventually said, okay, then I'm going to create the system where we can be able to access files or documents with a hyperlink. Okay, so that was his idea. So let's use a link to access files and all that. Now, this was a very fundamental concept that he had, but to ensure that this really comes through and people can appreciate what he has done, he had to come up with three main important technologies. So what was his central aim? His central aim was to ensure that information exchange is possible, documents exchange is possible, all right? And people can share information easily, right? So that was his whole idea. Now, how to make this practical or get people to be very comfortable with it, he had to develop three important technologies, and you do one here in computer science. The first one is HTML, right? How many of you know about HTML? Right, so you've done that, I'm sure. So he had to develop this markup language that was going to be used to structure the content. Okay, so it's not just enough to have the information and share it, but he wanted it to be user-friendly. So he needed to have this markup language so that he can code it and make the content more presentable. Are you guys with me? Okay, so you see how you form an idea and then you have to build technologies to shoot the idea up. That's how it is. Okay, so when you have an idea, you don't put it raw out there like that. You build a technology around it and you shoot it up. Now the second thing he did was to come up with what we call the Hypertext Transfer Protocol. That's the HTTP. You guys know about that, right? Okay, good. So the development of internet came up with TCP/IP. Now this guy also came up with this HTTP. Now what was the issue with the HTTP? He's just saying, well, let this be a form of protocol via which a certain web browser can communicate to a certain server sitting somewhere. Is that okay, guys? So then the third thing that he did was to come up with what we call the Uniform Resource Identifier, okay? And what you call URL or URI. Later it was changed to Uniform Resource Locators, okay, as URL. Okay, so these are the three nice technologies that he built around this idea of simply sharing information and sharing documents. Is that okay? So once he was able to do this, then the research group had to test and see how it looks, and they were really having fun with it. They were now able to share files across using this technology. So he would now build the website. What's now, we all do. Now he would now build the website, and the website is interfacing some files and documents, if you would say, on a server. Okay, so a web server. Then he came up with a browser via which people can access those files on a web server. So he was the first gentleman to come up with the idea of browsers and web server, so that's fantastic, isn't it? Yeah, that's him, eh? Okay. Right, so as at that time, he made people very happy with computers and accessing information on the internet, because it was fun and it was also user friendly as at the time. But as user friendly as it was very static. Okay, so you would only go there and consume information. You just scroll up and down like that. So that is what they call the Web 1.0. Are you guys with me? That's what they call what? Web 1.0. So you know about softwares, when you are releasing softwares, we say in versions, isn't it? Okay, so it means that's not the end of it. So one significant thing you can always remember about Web 1.0 is that it was not static, isn't it? So we would just scroll up and up, scroll up and up. Now, in 2000, so what we're talking about is in the 1980s and in the 1990s, right? So in the 2000s, then we came to what we call the Web 2.0. All right, so another name for Web 2.0 is the social web, if you would say. Okay, so now you can actually understand where the concept of the World Wide Web came from. So it came just from the Web 1.0 age. Okay, so now we have landed into Web 2.0, where we are basically not only viewing or consuming information, but we are also, as users, allowed to interact with the website, if you would say. So take a look at this. I want you to understand, as we move on from the versions of the webs, let me just use that word, you would realize quickly that what makes a a web generation different is the kind of technology that is built on a particular server to be accessed. Is that okay? So first, they were just building websites that was information-based and that's it. Now, Web 2.0 said, okay, let's build websites, but make it social, make it interactive. So you have examples like Facebook, Twitter, and what else? What else is interactive? I mean, your favorite ones like TikTok, isn't it? Yeah. How many of you learn something on TikTok? I don't think it's possible. Yeah. Okay, I should not start my thing here. Okay, so Web 2.0 is now fun. A lot of us are enjoying Web 2.0 because that's the generation we came to meet. And it's data driven, so like YouTube and all that, right? All these are examples of Web 2.0, so it's fantastic. Now, there is an emerging technology. This is the Web 3.0 that I'm going to talk to you about. Now, who can tell me what should drive Web 3.0? What should drive Web 3.0? Yes, what should make it different? Yes, anybody? Yes? Privacy, security. Yes, anybody? Decentralization. Okay, so these are fantastic facts and exactly true. So you would realize that in Web 2.0, it is data driven, user data is going in, but the limitation is that users don't have some control, so to say, on their own data. Is that okay? Okay, so, and although Web 2.0 is open, but it's not so extremely open, right? So there's just some limitations around it, and it's not completely user-centric, and it's not decentralized, okay, because the data is all sitting on a server somewhere and you are just reaching out to it with your web client, which is the browser. Okay, so the idea of Web 3.0, which is an emerging technology, I must say, and we have seen some developments on Web 3.0. I think Hive is really much into this stuff. The idea of it is to ensure that there is user-centric movement. Okay, so people now have control over their data, and once you have enough control over your data, that means you have privacy, isn't it? Okay, and then decentralization, that concept of decentralization. So this is now going to be, instead of data resting on a certain server elsewhere, now we are saying that everyone should have a copy of the data. Is that okay? Alright, so that is the idea of blockchain. So with blockchain being one of the bedrock technologies in the Web 3.0, you would find that it is pushing up the idea of people being in a network, being able to do their own thing, you know, build on their own conversation, share whatever thing they want to share, do any transactions they want to do without any third party. Okay, so it should be as private as possible, as decentralized as possible. And I think this is a nice idea, isn't it? Isn't it? Okay, so let's look at several technologies that are fundamental to Web 3.0. So I'll mention the first one, which is blockchain. Okay, so we have a very scientific definition for blockchain. It's a distributed ledger, blah, 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 right? Okay, so in this seminar, I don't think you need all those long stuff. So, if you want to think about blockchain, is there a picture there? Oh, my IT guys, you for be smart, eh? Okay, so if you want to think about blockchain, think about a network, okay? A network of, okay, how many of you know about P2P? How many of you have tried P2P before? In your dorm, you can try P2P, right? You just need a LAN cable, connect two pieces, isn't it? Right, and you're able to share files, isn't it? Okay, you don't need a third party, do you? Okay, but everybody is having a file sitting on their PC, isn't it? Okay, that's blockchain example. So game over. Alright, so you get the concept, right? So now, assume or think about P2P being bigger, right? So you have a lot of networked, you know, nodes. right? All in a network, and then they do their communication, sharing files here and there. But on top of that, we need to be able to build a technology, okay, that makes using this fantastic and enjoyable. So one of these technologies is the blockchain, as we talked about. Now, blockchain brings about very, very important attributes that everyone needs. The first one is transparency. Okay, what did I say? Okay, and then the second one is immutability. Okay, so you are able to make stuff immutable. In other words, it cannot be cleaned. Okay, you would need some level of consensus before something can be wiped away. Okay, and another thing is, I mean, not really a good English word like auditability. Okay, audit. You are able to have an audit trail of all transactions that went on within the network. Is that okay? Good. So if you look at this, and then last of all, which is fantastic, is the decentralization. Okay, so you have transparency, you have what? Immutability, and you have what? Auditability, and then you have what? Okay, so you know, one fantastic thing about decentralization, I think somebody should be smart about it, is interoperability. Are you guys with me? Interoperability. So I'll give you this example. So I mean, we published a work on this. You can check my Google Scholar to find out and read more about this. You look at the idea where you visit hospital, let's say KNUST hospital, right? And then let's say you are a patient with some acute illness. So let me use a very common thing, like maybe you sometimes have issues with your lungs, right? So you visit KNUST hospital and you have this doctor that takes care of you all the time. And because you're living within the vicinity, you are fine. But you travel to maybe Accra, and then when you went to Accra, the thing just came up again, right? So now you're having all the aches and everything, and then you move to another hospital. And because of your condition, you are not really able to narrate your history very well. But the doctor at KNUST knows you, knows your history, and if he was the one with you at Accra, it's nice, isn't it? You don't have to even struggle to talk and all that. But this other doctor that you meet knows nothing about you, and he would only have to take the information you are giving him, whether it's accurate or not, whether you are forgetting or not. Okay, then based on that, he will give you diagnosis. Now, this is terrible. This is dangerous because it leads to possibilities of medical errors. Okay, yeah, or wrong prescriptions and so on. Okay, so usually, if you are not a scientist, a medical scientist, you may not have accuracies in terms of expressing your own health condition. Is that okay? So it takes some time, then we're able to build on that. So with the idea of blockchain, I mean, in that paper we published, we were saying that now, why don't we ensure that the systems that are used within the hospitals are decentralized, so that with this idea of decentralization, if I move from hospital A to hospital B, then my data is always available, right? And then also within the blockchain network, I have control over how my data is being used. Because currently, you all visit the hospital, all your health data is there on the desktop there. You have no idea what it's used for. Do you have control over it? Okay, but the hospital usually runs some secondary analysis on your data. Okay, but you have no idea. Now, who likes it that you came to class and then there is a picture here, boom, that shows that this guy that is always yapping around, he has what? It's not nice, isn't it? So people's health condition should be as private as possible, right? And somebody having your health condition can blackmail you or something. Like, you don't want someone to know that you are having this kind of disease. So we want to ensure that people have control over how their data is used. And bringing in the concept of blockchain makes it very, very easy. So in that paper, we address that issue as well. How users can be very much aware what's happening to their data, and with their approval, stuff can happen to their data, so on and so forth. So these are just example applications that you can think of when you are talking about blockchain. So this technology is facilitated by what we call decentralized applications, smart contracts, and digital currencies. If my time is up, you tell me. Okay. Yeah, sometimes I talk too much. So let's speak it this way. You know about agreements, isn't it? Okay, so I want you to do something for me, so we all have to come to a consensus, right? So we agree on something and then we sign, right? Okay, so the idea of smart contract is that, well, maybe the agreement concepts are so many, so we code them, all right? Code all the agreements into a program and then get them to automatically execute based on some conditions. Okay, so let me give you an example so you can appreciate that. So let's just say that you are a freelancer, right? You are a freelancer, right? And then maybe you are a software programmer. And then you signed up to my company online on my blockchain system, let me just say so, right? And then I need to pay you, but I don't have to physically see you. And I have to make sure that you have really delivered before I pay you. Is that also? Now, I have to make sure you have delivered before I pay you. It's a condition. Is that also? Good. So I can code this into my smart contract. Now, when I code this into the smart contract, the condition that you have to meet before a payment will be made to you would be that you need to finish the work, maybe upload the work, and then once you do that, the smart contract automatically executes and then you are paid. You get the idea? So smart contracts are basically like agreements or concepts that we build into the program, and they have several applications. It's not only about payment. Okay, they have several applications. All right, that it's used all over, right? All over for many applications you can think about. Okay, so that's smart contract. At least you have something home, right? Okay, and then you would have smart contracts built, on a blockchain network like Ethereum. How many of you have heard of Ethereum, right? Okay, yeah, good. Okay, cool. So and so on. It talks about, as we were talking about, tokens and all that. So tokens are released; they are automatically released based on some conditions that are met. Sometimes conditions with time, so on. So many conditions, right? Okay. Now, where's Bash? Bash, where are you? He's gone. Very stubborn boy. You see this guy? That's that guy there. So last year he was a student I supervised. He's a first class student. You should clap for him. So last year he built a blockchain application for electronic voting. Okay, you should see him. He did that with Python. I don't know how he did that. You can ask him. Okay, but if you want to know more about it, that's him. So maybe after the talk, you can see him and find out how he did that, and the technology is still there, and he has even now developed it into such a way that we can use it for election, constituency-based elections, all right, where we are electing MPs and all that. At least that place you can fight a little, but when it gets to presidency, people don't want to joke about that. So maybe we'll start with assemblymen and all that, right? So yeah, so because once you have blockchain concept, then you introduce blockchain concept into electronic voting, then you are presenting transparency, all right? You are presenting a trail that people can always see. Nobody can fool here. If you voted, you vote. We all count at the same time, we all get the results. Is that also? So like we can even use the contracts to say that, okay, once all voting is done, release the results, and it's released, right? So like everything is going to be automatically and very, very nice. And people, because of the concept of immutability, people cannot really be taking things off, isn't it? So these are fine ideas you can really be looking at. So, I mean, last year he came to me, he said he wanted to do e-voting. I said there are many e-voting apps on the internet. So I don't want that. You should add blockchain technology. And he did that. I think at the start it was challenging, but he was able to do it. So another application, okay, so I talked about decentralized applications, I talked about smart contracts and digital currencies. Now, most of you are very fond of Bitcoins, isn't it? How many of you do Bitcoin here? I know some Tedia guy does that. You do Bitcoin, right? Hey, almost go, Charlie. Yeah. So the last time, where is that? I don't think he's here, right? So the last time I was going to Accra to do, there was a conference actually on cybersecurity, and then please listen. So once we got off the flight, then at the Accra airport, there was a student. I didn't even know he was a student, but he was just walking behind me, and then he goes like, "Sir," I said, "What do I know?" He said, "Oh, I'm a third-year student." I said, "Okay, why are you here? I mean, why don't you take a bus or something like you third-year student on a flight to work?" I was shocked. Then he told me he's coming for a Bitcoin conference in Accra, and I'm like, "Hey, so then you chatted, you were on the flight?" He said, "Oh, he has dollars. The guy is very rich." Okay, anyway, just study about Bitcoin, how they work, and try to do it. Yeah, the guy is rich. I don't take flight all the time, but I mean, for a student to take a flight to Accra for a conference. My flight was paid for. I don't know, but he will pay by his own Charlie, this world. Anyway, we teach you to be superheroes. So that's why they said teacher's reward is in heaven.
Two fingers, three fingers, four fingers. Now let's give it up for our earlier speakers. This is amazing. I think, funny enough, I have an apology because early on I passed the comment that this is not something you learn in school. I hope those who came with expectations, they are being met gradually. Yeah, I see they're not there. So I'll allow for 3 questions. 3 questions. You come up front because our microphone range is not so wide. So 3 questions. 3 questions, and then we'll move on to the third presentation. We'll be wrapping up very soon. So 3, I want 3 people. What's the first person? First person. Okay, 1, please come. Consistent face. 2, please come. And then the third person. 3, come. Okay, I'll allow you as well. Come. So 4.
CS2, that's computer science 2. And you mentioned about authentication without third parties. I want to know how, and is it that easy as compared to the third party authentication, and how is it done? Thank you.
The same question. Yeah. Okay, so Christian, computer science 1. I have a question about digital currency. So my first question about the digital currencies: how are these companies setting maybe a specific amount of money that they want to be on their system, and how is that currency regulated in such a way that maybe someone isn't adding more and inflating the numbers? And then also, what is the integration like between digital currency and physical currency, such that you are not just adding more money and then placing burdens on like physical financial regulatory bodies such as Bank of Ghana, etc., etc.
My name is Arthur, Computer Science 3.
Hello.
My question is, does the introduction of Web 3 mean that the, let me say, previous versions, that is Web 1 and Web 2, are no longer going to be used, as in, they will no longer be part of the new age of the internet that we are entering? Okay, so my question is, does the introduction of Web 3 mean that the previous versions, Web 1 and Web 2, does it mean that we are not going to use them any longer?
Mr. Mutala Mohammed Elias, and then my question is, he talked about the blockchain and then decentralization, and then I also know about quantum computing, and then quantum computing also does all this, but he didn't relate the Web 3 and then the quantum computing. So I want to know the relation between the Web 3 and then the quantum computing. Thank you.
Thank you very much. Doc, would you like to take?
Alright, so my co-host will do us the honor of giving them their souvenirs. I think Christian will be getting a lot of souvenirs today.
He's been taking a lot.
Yeah, Christian has already had some souvenirs, right? Yeah, so Christian will still go ahead. We ask for you to, yeah, so that is Godfrey, right? Good. And Christian. Godfred Christian, Arthur, and then Mount Luke. Okay, all right.
Please come forward.
Okay, so you got all the questions, right? So we take them one after the other. Yeah, the GIG, isn't it? Okay. So are we good? Okay, cool. This one. Okay, so currently, if you want to get yourself verified, okay, you have to create a username, and then you create a password, and then the password is hashed, stored in the database, and then you come the next time, you enter the password, is hashed again, and it's compared to a particular, the database, that the value that is stored in the database, and once it passes, then you are allowed to have access, isn't it? So with the decentralized identification, it's now going to be, you're going to be given a unified, globally accepted identifier. Okay, so that's it. So it has a bit of similarity with what we call single sign-on. I don't know if you know about that. Okay, so this is now moving to the level of making authentication a bit pretty easy. Okay, so now you're going to be having a globally known identifier that you can always use to authenticate by yourself, to have access to whatever you want. Okay, so what's the second question? Yeah, okay. So the second question is about digital currency. So, we have to separate what we have currently, what we call the central bank digital currency, right? Central bank digital currency, that one is regulated by the government, okay? So in Ghana, we have a lot of digital currency market, right? So for instance, Momo and what else? Ghana Pay, Vodafone Cash and all that, right? So they are all digital currencies, and they are central bank digital currencies. In other words, the Bank of Ghana has some level of authority on how these technologies are used here and there. But when we talk about the decentralized digital currencies, where we can refer to things like blockchain using blockchain technology, like things like Bitcoin and all this stuff, right? So here we are talking about a kind of currency frame that is not regulated by any central bank. Okay, is that clear? Okay, so this is going to be regulated by the people on the network. They develop their own, smart contracts that are used, and their own technology behind that. Now, the originators of the technologies would really come up with every frame for that, and all the regulations surrounding it, how you can be a part of this network, the control of the currency, and what the currency can be used for. Please, are you guys with me? So that is controlled within the ecosystem, and people who join that, people who engage in that, they know. But they sometimes also try to relate that to normal currency. So for instance, if you have an exchange rate app on your phone, right, you can check, or you can even go to Google and check how much one Bitcoin is against US dollar. Can someone check now? Is what? What? One Bitcoin is how much?
$36,000.
Yeah, one Bitcoin is $36,000, right? So guys, do you understand what that means? Right, so now when you are within the network, okay, so it's like trading. I don't know if you guys know about trading, right? So you are within the network, you buy, you sell, you have these tokens here and there, okay, and at the point if you want to turn things over, you know how much you have it in terms of cash, right? Okay, and then there are things that you could use that for. They are all defined within the particular financial decentralized application. Bitcoin is not the only one. There are several other. I have seen Binance. There are several other finance technologies that are running on blockchain, and you want to look at that, right? Okay. Okay, currently, if you talk about integration, I have not yet seen a very smooth one, a smooth adoption of, that transfer. I think certain countries are making attempts, for instance, China and for instance in the US, okay? These are making attempts to look at how these can be smoothly done. But people have other ways of using this. Okay, they have other ways of using the cash, if you'd say, earned from this. Okay, not necessarily maybe pulling it down as hard cash, but there are other ways to use it which are also equally profitable, and it translates into whatever you want. Okay, yeah. Okay, so someone is asking, is the introduction of Web3 making 1 and 2 absent? Well, so you should understand the concept. Whether Web 1, Web 2, Web 3, it's dependent on the technology, right? So and then it's all more or less about paradigm. So you can think about it. If I build a website that I make it completely static, it means I am living in 1.0. Is that also? So it's just only information. People consume that, but it does not mean that there is no current technology. Are you understanding my point? It's like currently there is Windows 11. And then you want to use XP. Okay, so yeah, you can use XP. Nobody is saying throw XP away, right? Or like there is iPhone 14 and all that, and then you say you want to use Nokia 3310. Yeah, like if you can find it, just use it. But still, technology is moving forward. So 1.0, you may have a website that is simply 1.0 stuff, and you can have also a web application that is at the level of Web 3.0. Okay, so the technology is there, so we rather want to move upwards. It doesn't clear them off, actually. Okay, the last one is so the guy is asking, okay, microphone. First, he said that he knows about quantum computing, and how does it connect to Web 3.0 and all that? Okay, so let me tell you, quantum computing is like this. Okay, so it's just we are looking at ways of coming up with computers with higher performance. Okay, that can do a lot of computations better than what we currently have. Now, usually we know that everything we do on the computer is translated into bits, right? So people are looking at different ways of representation of our information we put on the system, so that if we can have a computation system that is faster than binary, then we can achieve faster computation, so to say, right? So there is one technology called RNS. I think you can look at that later. Residual number system is a kind of number system that, by research, they are saying it's faster than bitwise operation. Okay, that's the idea in that domain. But then we are also looking at quantum computers where we are dealing with qubits. Okay, and then the idea about developing quantum computers is to have computers that are extremely powerful, can do a very enhanced computation, so on and so forth. Right. So, if you think about quantum computers, then you are thinking about computer performance. All right, what it can do, so on and so forth. So I don't see, Okay, so if you are thinking about the fact that quantum computers could be used in mining, okay, in blockchain, so to say, I agree with you. So that could be a connection there, probably. And then we also know that blockchain is a Web 3 technology, so that's fine. Okay, so maybe that's why I see a little bit of connection where you want to have high performing computers to mine and so on and so forth, right? Okay, yeah. Thank you.
All right, thank you so much. I think we can do better.